Alright, time for another draft science video presentation. So, well, Stephen Bros made 4 minutes worth of video. Cartoons, we'll call them. Stephen Bro cartoons. 2 of them, I guess he's entering in the Veritasium contest. Somehow he thinks what he's putting in these videos is somehow relevant to the subject, which is supposed to be some kind of, some unique and interesting parts of physics, and so he thinks this is a suitable entry. Interesting. So anyway, let's see if this one's animated. No animation here though. All right. Anyway, debunking Gary, whatever. So there's just this constant litany of accusations. I do have my one of the slides from Stephen. Just as example. I couldn't find that. I have the piece of paper somewhere that he had it all taped to. Okay, yeah. Something I didn't ask for, and he just insists that I should be the most grateful person on earth that he went to the trouble to cut up some film, and glue it on a piece of paper and send it to me, and now I owe him for the rest of my life for some reason. I mean, insane.
This answer is so obvious. It's causing the envelope.
Great.
Okay, let's check Gary's claim that the envelope is caused by the impediment. I'm sorry for laughing, but he is so funny.
So what is it caused by, Steve? I mean, the math is the math. You do understand that, right? So I won't bother talking to Steve, right? But I'm just saying, the audience, the math is really simple. It only has 3 variables in it. Okay, it has the distance to the target, the width of things. Okay, and obviously Steve has already pointed out it doesn't matter whether the width is an impediment or it's an opening. It doesn't matter. They have the same effect. So it's clearly the distance between surfaces that is dictating the mathematics everyone's using, Steve. There's nothing else in the equation except the distance between the surfaces, the distance to the target, and the frequency of the light. So if you wish to explain to me how the conventional, I know you don't do math, but I mean, how do you think they're doing it? The only variable is the distance between the surfaces. They must have something to do with it. Okay, yeah, I wasn't going to talk to him. What an idiot.
Because he gets so much wrong. Let's use the slit that I sent him 3 years ago. He should still have.
Yes, so he's going to show them. He sent me, like 6 of these, okay, without the cover. So he's cut them and sent me little pieces. And you can see this one, he had cut a slit in this one and put tape on it and some kind of crap. All right, and and again, the whole point I'm arguing is these slits aren't really made for investigating the 2-slit experiment. They're made for demonstrating what conventional physics wants to demonstrate. This is for high schools and colleges to use, so they can keep propagandizing a wave theory.
Conveniently, it's got 4 different impediments on it, 4 different widths, so it should make 4 different envelopes, shouldn't it? I mean, if Gary's right that the impediment size controls it.
Obviously, it's the smallest distance is the argument. So yes, if they're double slit experiments, you can't get smaller distance than the impediment distance technically, okay? Because the other distance is going to be bigger. Now, obviously, it's 4 sources, so the 4 sources are going in all directions. But regardless, these are the only distances that are in the experiment. There's got to be, that's why I'm writing this, is to sit there and provoke people to get more explicit in what they're saying, okay, so we can know for certain the right way to say it. But clearly the distances between the surfaces is a huge factor in deciding what patterns are going to be.
The envelope size.
A single impediment is causing the envelope.
Then he would look pretty silly, wouldn't he?
So he just keeps doing this gazoo thing, this whole thing. What is this shit? So you have some evidence, show the evidence.
If these 4 different impediment sizes actually causes exactly the same envelope, that would be embarrassing, wouldn't it?
So this is the
All right, so let's see what he's come up with. So what would his theory be?
1 millimeter slit centers, in other words 0.85 impediment. I've marked them up as accurately as I reasonably can.
Now the next one is a smaller 0.6 impediment. 0.15 slit width is what stays consistent throughout all the...
So he's not drawing it or showing it in any way. So he's saying the impediment gets bigger, but the slit width stays the same. What exactly are you saying? Why can't you draw a picture of anything ever? Why can't you illustrate what you are doing? Oh, this is so irritating. He shows 15 seconds. Well, it wasn't 15 seconds, right? It was less than, what, 3 seconds, 2 seconds of his evidence. We get to look at it, and it's gone. So what he's saying is that this distance stays the same, and this distance somehow is the only thing getting changed. Is that your argument, Steve? That this impediment gets bigger, okay, and this distance stays the same. Is that what you're... Well, there's no point in me asking the question, right? Because we're not going to get an answer. And we certainly can't see it in this image.
Turns out that's what's really causing the envelope, but let's pretend we don't know.
Okay, let's see what's really causing it. Let's find out what's really causing it. And what's causing the double maxima in the center? Do you have that explanation too?
Envelope, but let's pretend we don't know.
Okay, so I have to go back further.
Impediment. 0.15 slit width is what stays consistent throughout all these. Turns out that...
So the slit width stays consistent. That means this outside dimension is getting bigger. So this is happening, right? Okay, so this is getting wider, and this gets, a little bit wider, and this so the big distance, this little bars should be getting smaller. Okay, so what he's done, probably the mistake he's made, whatever the error he's made, is he's counting the little bars inside. Well, yeah, the little bars inside are going to be smaller. So, yeah, there's going to be more of them. So let's see if that's what he actually does. If he just counts the little bars inside of the envelope and then says the envelope changed size. No, that didn't happen, Steve. Little bars change size. So let's see. See if he just drew it. Then we know what he was talking about.
That's what's really causing the envelope, but let's pretend we don't know that for now.
Okay, you know it, I don't know it.
I'll mark this up. Perhaps you can see already that it's the same envelope. Okay, I've marked it up and you can see that it lines up with the previous mark. Even though the impediment is changing, the envelope isn't changing.
So the impediment is changing, but the envelope's not changing. So this is his argument. So nothing changed. So you have 2 different sizes and nothing changed. I don't think that happened.
Single impediment.
All right, so that's his evidence. That's all we're going to get before he goes back to gazooing and this nonsense. So he doesn't tell us anything about which one he's using. He's got 4 of them. Did he do 4? Did he show us all 4? No. Did he show us how the pattern were different at all? No.
Stays consistent throughout all these. Turns out that's what's really causing the envelope, but let's pretend we don't know that for now.
I'll mark this.
Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, visible bars.
Perhaps you can see already that it's the same envelope. Okay, I've marked.
All right, so and this is a new one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's exactly the same pattern. So somehow, using a different slit with different openings, he created exactly the same pattern. Does anybody think that's possible? Do you think that's possible? I don't think that's possible, frankly. No, I don't think so.
And you can see that it lines up with the previous mark. Even though the impediment is changing. Yeah.
So even though he changed the size of the slits, right, or he made the outside slits much wider, you're either changing the size of the openings or you're changing the, but neither one changed. Let's just say the same number of bars, inside the same envelope. And he says this is proof that all slits look exactly alike. Oh, that would be silly, wouldn't it?
Envelope isn't changing, so again Gary's theory is wrong.
The single impediment is causing the envelope.
Let's go even smaller, 0.35 impediment. See if that changes the envelope.
0.35.
So he could show this thing better, right? And he could actually say something about what it is. So 0.35 of what, a micrometer? So we're talking about 6 wavelengths, 9 wavelengths of light, something like that. So they're very big. There's only 9 of them per 90 degrees. So a total of 18 viewable, potentially viewable.
5 micron impediment. And there it is. Oh, it looks a lot better in the dark, doesn't it? Gary should be able to do this himself.
Yeah, why would I do this myself? Again, why keep doing sloppy, crappy, shitty experiments? Why shouldn't they be done really precisely and well? Not this crap. I drew it on a thing with my pencil and crayons and stuff. Alright, so anyway, 1, 2, 3, 4, 5, 6, 7. You know, we got these little ones here, though, that are still pretty, you know, that looks like the second bunch there and the second bunch there. So 1, 2, 3, 4, 5, 6, 7. Okay, that's all we got in the central one. So we had 9, now we got 7. We're using a smaller slit. You know, so there's no real point, right? Because he really wasn't clear on whether he's making the slits wider or whether he's crunching the slits. The slits are getting narrower to make the impediment bigger. So we don't have any clarity on this at all.
Here we go again. So the envelope isn't changing with impediment width, is it?
The single impediment is causing the envelope.
The envelope is changing in the sense that the relationship between the envelope and the little lines inside of it is the relationship I'm talking about. So I don't know what you're talking about, but that's what I'm talking about.
Do we really have to do the last one? Okay, just here. I know you care about detail. There we go. 100 microns.
All right, so now we only have 3 nodes inside of the envelope pattern. But as you can see, they're somehow bigger dots. Why would that be? Have to think about it, right? Why would they get bigger? If the slits were the same size, if the openings were the same size, the dots shouldn't be getting any bigger. So he's making the impediment smaller. All right, and that wouldn't work, right? Because he's making the impediment smaller, the envelope's going to get bigger. So can't do that. Yeah, sorry, I have no explanation. I don't really have an obligation to explain this mess.
More tricky one to mark, really, I think. There are less sub-fringes. Quite a confused pattern, really, when you get to this stage.
Not the impediment, the slit width. That's the thing that stays the same in these 4 examples.
Okay, the slit width stayed the same. That means the outside slits had to get much further apart. So you're also saying that it doesn't matter how many wavelengths are in that distance, that's not causing the effect. Now, I'm just saying, well, what's your logic? Because everybody's math think that's how it works. Everyone's math. Everyone's. There's no math that isn't using the distance, okay, as the cause of the effect. How many you're going to have. Professor Lewin's saying it when he's using the variable slit. The slit gets narrower and narrower. The pattern gets wider and wider. You're saying it doesn't work that way.
That's why the envelope stays the same, because the envelope is being created by the slit width.
So he said it again, okay, so fine, you can say it all you want, all right, but it's being created by a distance, and you can't keep the distances the same and then say I changed the experiment. So you're saying you moved the slits further away. Is that what you're saying? You took the same slits and you're just moving them further away, and you're saying it has no effect on the pattern. Doesn't make smaller bars, doesn't do anything. You know, nothing changes. At least that's in your first example, nothing changed.
How did Gary manage to fuck up?
Alright, so this is what he thinks is some sort of proof. So this horrible, crappy, idiotic, undocumented in any kind of real way evidence. Okay, great. Yeah, sorry, not great. You could have at least, you know, I mean, at least take a close-up picture of the slide. I mean, I don't know if I can probably do it with this shitty camera, right? Alright, how close can I get? Okay, I'd have to turn the autofocus on. Alright, but I can definitely fix that, okay, with a simple fix, right? You know, Steven's all big on doing all these experiments. I mean, I just put a magnifying glass in front of there, and you'll be able to see exactly what those little slits are doing. Yeah, you can almost see it there. Maybe a white piece of paper behind it. Yellow will have to do. Alright, now the light doesn't come through, and so now I have to get enough light to bounce off of it, which I don't have. Okay, never mind. But anyway, so we almost have that experiment completed, where we did the experiment where we actually showed what the slit looks like. And then we can wonder about the numbers that are written on it. So that's the only real value of this, is what I want to show was these are the incomprehensible. Alright, let's see. Let me turn on autofocus to see if it can focus this close. Can't hurt to try, right? There's a focus here somewhere, right? Yeah, maybe there isn't. Maybe I can't focus. It is, you know, Linux. Auto, exposure, sharpness, temperature, frequency, gain. It doesn't look like there's anything called focus. Yeah, so I'm fucked. Alright. Sorry about that. But I should have had a magnifying glass ready. I know I have one right here somewhere on this desk, but well, let me take a pause and see if I can find it. Pause over here. Yeah, this is the pause. Yeah. Alright, should be back enough. Alright, so you can almost see this, so close enough. It's written backwards, no doubt, right? It's going to end up showing up backwards. Alright, let's see if I can get that in focus, just about there. Okay, so it says B.075. Then, you know, that's a small case B. And then you have another B. Okay, 0.1 mm. I mean, it's just indecipherable crap that's written on this thing. So let's just understand that. But anyway, the point is who cares? You can just look at it. Alright, if you can zoom in enough, let's see if I can zoom in enough, turn it the right way. Oh, well, we can almost get an image of it, not quite. But they're tiny little impediments in this case, little tiny ones. And the openings appear to be the same size. So, who knows what this exact one is. Let's see if I move this and move that. Almost, but no cigar. Alright. Doesn't matter. So, anyway. Yeah. So, I don't know exactly what Steve's theory is. Well, how did the two slits combine? Because it's clearly not two single slit patterns combined. What's combining has to be some kind of new surface relationships, and those would be the new surface relationship, so that when you move the slits into each other, this relationship is the new relationship, and this one out here is a new relationship. You could, you know, you can still say this one and this one, because they're still four sources. I'm just saying, for the purpose of seeing why the two sources are different, is just to understand that the difference between these two simple sources is is that this didn't exist. Okay, the relationship of these two to these two did not exist until you move the two next to each other. And that's the new thing, and that's why you have a new pattern. It's because you created a new relationship.
A single impediment is causing the envelope.
Let's go even smaller. Point.
Alright, we already did all this, right? Yeah. Okay, so yes, it's just too shitty. Yeah, okay, fine, you think you proved something. I don't think you did. A little bit short, in my opinion. Alright, moving on. Next, Dungan crater. Yeah, I mean, this is like 1942 internet. I mean, this is so old. This accusation is just so useless. But go ahead, play your little. Oh, this is such a funny little game. It's like being entertained. Like he's like a little kid. He's entertained by pin the tail on the asshole. Ugh.
1 minute on why.
I don't know why his volume is insanely loud.
Single photon version was done in 60s.
And I don't know what you're talking about, the 60s. It was done in 1747.
Or something. So he cut the, the or something off. Obviously, I'm just making up a date. It was done with non-electric lights. Okay, so it was before the electric light. Okay, but it had to be after the invention of photographic film, because they did use a piece of silver oxide to take the image. And it wasn't a double slit, they just did a single impediment. They just put an object in, okay, and picked up the fringes around the object. And it's a 2-page, I saw it, okay, it's archived in the Royal Institution. It's a paper written, in handwritten paper, okay, with a little drawing. Okay, so I'm just saying, if somebody's going to argue that they had single electron experiments before single photon experiments, I'm going to say, nah, no real chance. That's nonsense. They knew this concept long before they even knew what electrons were.
Gary, how is this even possible, considering the fact that the double slit experiment wasn't even done?
So he thinks this is important. And again, it's not the double slit. They did the single impediment. But it doesn't matter. They obviously was after 1800s because they had to film it, right? There's no other way to get an image of it except some kind of film, right? So I don't know whether that's the definition of when photography was invented, but I mean, clearly they had to be taking an image on something. Now, see, that's the part, maybe there was something where they could view it, but it wasn't permanent, But I'm just saying, so it doesn't really matter. It's long before we could manipulate electrons. It's just silly to say, we did it with the electron experiment first. We did it inside an electron microscope first. Yeah, I don't think we, and look, I can play Feynman, or is it Lewin? Lewin, I think, well, it's Feynman or Lewin, recite a whole story about a French guy who did it, all right, way back when, all right, and he actually went sailing for a month while the experiment was conducted. I mean, these are in my old videos, so these are real quotes. I mean, it really happened. So I'm just saying, and then I asked Dr. Lincoln for his source, okay, and he didn't give me any source, okay? So I'm just saying, you think it's true that we did the electron experiment first. Fine, go ahead and think so. I think you're an idiot if you think that's true. I think you're an idiot for like 9 zillion other reasons. But one of the reasons why I think you're just a belligerent idiot is I don't think you believe that we did the electron experiment first. Single electron experiment. I don't even know if you know that we can even do a single electron experiment, but I'm quite certain we didn't image, okay, or create fringes with electrons first, single electrons.
Until 1801, and you were claiming that 50 odd years before that, a variation of it.
I claimed it was done long before we could manipulate electrons, was the point. So I described clearly what I remembered. So this is all just horse shit.
Done. You're a moron, Gary.
It was done in France.
So yeah, and so there was a French guy is the story, right? But when you go to find it, you don't find a French guy, you find a British guy, like, I thought it was an H name, like Hodge or Hook, or it was one of those, Lodge, maybe Lodge. It was one of those guys who did it.
The real one was done in England. Pick a number.
So yeah, I said pick a number, right? Obviously, I don't know. I don't remember the date. I just remember it was handwritten on what is obviously yellow paper now. So it's really old, and it wasn't an electric light. I mean, the fact that they were using a gas light or an oil lamp, okay, is a pretty good indication that it was a long fucking time ago. So this is his game. This is his big victory. This is the best you can fucking do.
1778.
Yeah, let's all just pick a number. Let's all just guess the history.
I know, I wasn't making some declaration about some absolute fact. I was just pointing out the fact, okay, that such a paper exists. Now, I Googled it and I can't find it because you can't find anything on Google anymore. So, I mean, and the Royal Institution doesn't even have an archive page of papers submitted by members of the Royal Institution, so I couldn't even find it that way. But it was clearly a PDF file where they had an image of the paper, okay? The paper wasn't converted into text, it was an image of the handwritten paper.
Like Gary does. Let's all just guess how things work.
Little rod here, no rod. Just pulls this rod in and out.
Let's all...
So he's going back on this speaker thing again, which is exactly what I'm describing actually happens, okay, with some devices that are called speakers. So again, he thinks there's only one kind of speaker, the paper, magnetic speaker. There's no other kind of speaker ever invented. You know, even the way we know Edison just made one out of a horn, a piece of metal.
Just guess our way through physics like Gary does. No, that's a bad idea.
Lord, somebody did it.
Let's do this. So everybody, the great alternative is this fucking horse shit. Jump cuts, physics by, didn't I show you the facts? Here, isn't that, there, I proved it, right? You saw that, right? Yes, I proved it, right? And he won't answer a single fucking question you ask, right? So he won't explain why he thinks Professor Lewin is right, and yet he's wrong. Right? He won't explain to us why Professor Lewin would say something stupid like kinetic energy is conserved when Brosey knows, no it isn't.
Such attention to detail.
Yeah, whatever. And
He talks about detail, okay, and we saw what his experiments look like.
photographic film.
What in the name of God are you talking about? Photography.
So again, like I said, obviously I was just throwing a number out there. It looked like an old piece of paper it was written on. Yeah, I didn't archive it and, put it in a notebook and write down all the details and all that stuff. I just read the paper, said, oh, interesting, but still failed because you still don't know whether they're single photons, as I've already explained, because blocking photons doesn't necessarily stop them, it just breaks them. So it doesn't work.
It wasn't even invented for another 100 years.
No, it wasn't 100 years. Actually, it was only 70 years. Right? I think the first photo is, 1830 or something? So it's 90 years, or 86 years. So you got it wrong. Oh, such precision. I mean, he's such a hypocrite. Play these games. Oh, such an asshole. All right, done. Last one.
Here is a scientist at work. He is measuring the size of these slits. How is he doing it? He's using his...
Okay, whatever. So obviously I don't give a fuck. I don't, you can just keep playing this game like, oh, look, it's obvious exactly what this is. See, there's a number, 2, 3, 4, 5. There, it's obvious what it is. It's not so obvious.
Eyes. Like all good scientists, he guesses. Are these tiny or large?
Whatever. Again, so Stephen Bro says he's proven. Okay. What was the one in the other video? I forgot. That's how stunned and impressed I was by his proof that I've now forgotten.
It's a very skilled job. Let's just listen in.
Tiny obstructions. So probably somewhere close to, the
If only there were an easy way.
Whatever. So, again, so it says 0.15 millimeter. We know there's no 0.15 millimeter here, right? I mean, except for this, this one? Which one's 0.5 millimeters? This is 0.25 millimeters, right? So it's a full quarter of a millimeter, which is rather huge. Anyway.
finding out the size of the slits, and because of all his years of experience, he's only off by a factor of 200. That's very good.
And again, who cares? I mean, until you document a distance that you're projecting it to and show us that it somehow doesn't work, the relationship that I pointed out doesn't work. That is the relationship of the outside surfaces to the inside surfaces. Then you're showing nothing. And again, your argument is basically saying that there isn't a rigid relationship between distances and how many path length differences you can have. So just understand what he's saying is these distances do not determine, okay, how many points you could have in space, all right, where there'll be this line, okay, we'll have to, well, see, the way you draw it always screws it up because the distance ends up being, you know, the point sources are very close to each other, so you know when you draw it you end up making it look like this one's going over to this one in more space than the space between the slits, and that's not the idea. The idea is that you're taking this vector and going into the space on the other side of this vector's 90 degrees. And so he's saying that there's not a fixed number of points, okay, where you could have possible in phase, that is a full wavelength of difference. So he's not saying it's not fixed based on this distance between the point sources. That's not deciding when everybody's math is using that. So he keeps saying he's Dunning-Kruggering me. No, you're Dunning-Kruggering Richard Feynman and Professor Lewin. So why don't you play their videos and make the same argument? Because they're saying essentially the same thing I'm saying. I've just been smart enough to understand how they fucked it up. How they fucked up something so simple.
For this scientist, because he really is a fucking moron.
So he's proving I'm a moron by showing you something there's no way you could know what this means, right? It's what does this mean? Oh, this means something? I don't know what this means. 2, 3, 4, 5. Well, that's really interesting. What does that mean? Yo, I don't know.
Do not worry about the technical jargon. You will soon pick it up.
The tiny, probably somewhere close to.
So he just, this is how he responds, okay? Just understand. So if I did this to his videos, right? So I'll play, okay, so let's just start the video. Okay.
A wavelength of.
Okay, that's all I'm going to play there, and then I'll jump to here, and I'll play a little bit. Okay, and then I'll jump to here, and then I'll do that, and then I'll do that, and then I'll do that.
Because of all his years of experience.
And we'll call that some sort of rational response. No, it's useless. So again, he thinks I can't do the same stupid thing, this stupid tactic. Why would I use this tactic? I'd be humiliated and embarrassed if I had to resort to this horse shit. And a kazoo in the background, no less. I would be profoundly embarrassed the minute I have to do that to make an argument. I'm just basically screaming at anybody listening, I fail. I can't do it right. I can't do it like a man. I have to do it like a kazoo sissy.
You will soon pick it up.
The tiny, probably somewhere close.
So he just keeps repeating the same clip. And yes, obviously my argument is that the best way to do the experiment was nice big openings and nice solid impediments. Yay. You know, good pattern that way.
Close to a wavelength of light.
No, 200 times bigger actually.
Fine. So I'm just saying this is all worth everybody understanding. So when conventional physics says infinitesimally small slits, they're meaning slits that are really so small that you couldn't even cut one with a razor blade. It's just you'd almost be hopeless. Okay, because you know I guess I'm wrong about human hairs. Human hairs are kind of fat actually. And they're actually very uneven, so they're not very good for doing the experiment, frankly. Because that's almost 200 wavelengths, right? Or at least 75 wavelengths. in just a human hair, that tiny little line. So can you imagine how small the slits have to be when they suggest that they should be, less than a wavelength? Oh, well, no point in anybody even trying to make less than a wavelength distance in a slit experiment, right?
You hear a squelching noise? That's him pulling shit out of his arms.
Oh, whatever. So just more non-responsive, just junk, right? So I've made a 15-minute video. It now has errors in it that he could pick apart, but frankly, he can't pick apart all of the aspects of it, all the points made in it about the detector experiments that have never been done, all the other arguments that have been made that he has no opinion on. He says nothing. Except to imply that there's some, that it's inaccurate to report on the fact that, Walter Lewin did get caught shenaniganing. I mean, it wasn't one person, it was like 10 women, okay? So it's not like, oh, gee, he was set up. You get real, all right? It's just a fact, all right? I don't care. It's not that interesting to me, but it is a fact. Okay, so, and they get hysterical because somehow that's persecution and that's unfair, and it's no, it's not persecution. Oh, but anyway, it's whatever. And so, what's your argument, Steve? Do you think so? Steve didn't defend the argument that the electron experiment was done first. You just defended the point that I didn't say it, okay, in a way that was precise enough, because I don't remember the date of the paper I read. And so because I don't remember the date of the paper I read, even though I know everything about it, in the sense that I read it, I saw the drawings, I saw the way it was written very well, script writing done very, very well. So we know it wasn't. We know it had to be old because nobody writes that well anymore. But anyway, it doesn't matter, right? And for what? For what? Just this minor little point. All right. And I'm just saying. So Steve is saying that Dr. Lincoln was right, even though we don't have the source he used, and I can't even imagine what electron experiment he's talking about. That was the first single electron experiment. Where was that conducted? The single electron experiment. Anyway, there's just no point. But anyway, okay, that's enough of this. So there wasn't anything that interesting in all of this mush. So he's like I said, he has, from his own opinion, proven that you can change the number of nodes, okay, the number of points that create interference by moving an impediment between a slit. So even though the slit creates a certain number of nodes, sticking the impediment in, it creates a different number of nodes. So there's a different number of path length differences for those two surfaces. Now, I'm saying mathematically that can't work. It can't be right. But anyway, we'll see. We'll just continue with this and see if we can glean some better evidence than this. And again, the real point to argue is this idea has been around since Isaac Newton, and then the Young experiment, and all of this talk is the whole foundation of quantum mechanics, and look how little precision we have in terms of conventional physics providing us evidence. I mean, we should just be able to look it up. We should just be able to go to a slide of the experiment done at every size almost. Every whole number increment of a size, right? I mean, half micron, quarter micron, right down the scale. We should be able to see all of them, all the images, and just compare them. But there's no such index. And this is the cornerstone of this is their foundational experiment. And just look how weak the evidence is. So anyway, and he has no competing theory. So again, his explanation is nothing. Why are there two patterns, Steve? What's your explanation? Why is the central maxima twice as big, Steve? What's your explanation? I mean, the key one, right? I mean, the one he's obviously wrong on is, the idea of the two vectors that meet. the same length lines and they meet. So therefore it has to be a maxima when that all happens in less than a millimeter. Okay, you can't possibly create a 5 centimeter node, or even a 4, whatever the size is you're projecting on a screen. Can't possibly create that because it happened inside of 1 millimeter. So will we get an answer to that? No. Will you say anything on the subject? I mean, even the point. I mean, again, I can just reiterate. It's a significant point to understanding how the math is done. Is that one of these vectors, you have to understand that they are two different. They're going to make two separate arcs from their own 90 degrees. So each of the point sources, each of the surfaces, is in a different location doing a different thing. And when you go inside of it, well, you're going inside of 1 millimeter. Okay, this is a tiny little space you're going inside of. And the ones that go outside, one of these, this vector has to cross into this one's arc. This is the line that's variable. So this is the one that can be any, that you can make larger. This one has to stay the L distance. This one has to stay the radius distance. And all you're trying to figure out is when is this one a path length different. So what's Steve's argument? That this one made the center maxima. So this one inside of 1 millimeter made a maxima this big. Even though the light can only be inside of that 1 millimeter, somehow it made a big giant node here. When the rational answer is no, the path length difference for one wavelength starts here and here, making two nodes here and another node here, and you're just turning two nodes into one node. It just looks like one node because the center is full of other light that was produced by the opening and by the 1 little millimeter. He's not going to be able to counter argue that with anything rational. Alright. So, enough of a video. I should think and see if there's anything else to comment on. Well, for now, no. Eventually, maybe I'll do some of these experiments again. I did them in the past, and I didn't worry too much about any exact geometry. I did, take a close-up image of the slit I was using and its dimensions and try to control that as much as I could to try to get some idea of what's being produced. But I didn't have a full theory, so I didn't bother getting all those facts correct. As Steve points out, I mean, he's saying that there's twice as many nodes. So the number of nodes, say if there's 10 wavelengths in the distance, or 200, that means there's 200 in each quarter. Okay, so there's a total of 400 nodes, ons and offs. 400 pairs. But anyway, so that's a good fact. If that's a fact, good. That's helpful. But again, the real point is the relationship between the two surfaces. And what the nodes are telling you is the relationship between two surfaces. So if there's 7 little notches inside of the envelope, well, that's double the regular node, right? So the regular node is 4, let's say. If it's 7, then it's got to be 3. Well, it's 3 or 4. It doesn't matter for a regular node size. Okay, so then the relationship is from the envelope to the other impediment, it's got to be something like 4 to 1. So the distance is, this distance is 4 times bigger than the impediment distance. That kind of thing. That's what it's telling you. Alright, anyway. Till the next time and such. Yeah, that's probably enough. I mean, the important one was to point out the hair, too. See, because that does throw a little bit of a monkey wrench in that creates a little bit of uncertainty. And you do get a messy pattern as a result. So a hair isn't very small, but it's really uneven. So that's the problem with a hair. It's got a bunch of scales sticking out of it. But the interesting thing is if you use a very thin impediment, something that is maybe just 10 wavelengths or something, some really small wire, okay, as the impediment. Yeah, it's still going to, 10 would be 10. I mean, it should be creating 10 nodes, or the envelope should be very big and lots of bars in the envelope. But you might not see the other parts of the envelope. So that part defeats it. But in a way, if the 2 point sources are very close together, you can sort of understand that you can't make very good path length differences from these other points. And so it ends up being just a 3 point source experiment in some respects. So that's something to consider. What's the implication of just having 3 point sources? And whether all 3 have to be in phase. Yeah. Anyway. But that's the other part of this, right? See, everybody's arguing about it, and the thing to figure out, too, is why is there so much spread? There's supposed to be a point where you're in phase. But obviously we see light that's in lots of points that aren't supposed to be in phase. There's some degree of out of phase. And obviously there seems to be a bias that makes the light spots bigger than the dark spots. So there's a tendency to forgive being out of phase more than forgiving being in phase. But anyway, we'll see. Yeah, so I mean the list is below. I'm saying 90% of what's on that little simple statement is true. So let's argue it. But I don't want to argue it this way. This is just a waste of time. This childish nonsense. Just really poor human performance. Anyway, till the next time and such. This has been a Draft Physics and Draft Science on YouTube video presentation.